Alright guys, so in the last video we talked about the two formulas for arc length and for the area of a sector. What we're going to do is we're going to take a look at your classwork packet, page 7, question number 10. Once again, that's page 7, question number 10. And we're actually going to do two things. We're going to do what they ask us, which is to find the arc length, but we're also going to find the area of a sector. And this is the same thing I'm actually going to ask you to do on the homework for this section. There'll be two spaces to enter your answer, and I'll ask for both arc length and for the area of a sector. All right. The reason is really looking more toward what would have been the EOC, but it's now going to be SAT next year. There will be questions on your PSAT and your SAT that require you to find both area of a sector and arc length. So it's good for you guys to be familiar with both. Okay? So let's take a look first at question number 10. Okay? So they give us a circle right here. All right? We've got ourselves two diameters. By the way, anytime you guys see diameters, you should automatically start thinking linear pairs, stuff adding up to 180, right? Because diameters split a circle into two semicircles, which are 180 degrees each. All right, so I got E, A, D, and we're good. Now, they actually give us the radius here. They tell us that EB is 15, which is really nice, because that gives us one of the two things that I need. Now, they asked me to find the length of arc CD, so they want me to find how long this thing actually is. Before I can do that, though, I actually need to know the angle right here that I'm going to use. If this is 68, this is a linear pair, and this is the angle I want, what plus 68 equals 180? Well, 112 degrees. So what I'm going to do now is I'm simply going to plug into a formula. This is my angle, this is my theta. This right here, the 15, that is my radius. And so all I have to do is plug in. So in this particular case, I would do 112 over 360 times 2 pi 15. So, using our handy-dandy calculators, and remember to round to the nearest tenth at the very end, let's see what we can do. So let's see, 112 divided by 360 equals, 112 divided by 360 equals times 2 times pi times 15. And what do we get? When you round to the nearest tenth, we get around, around like, what, 29.3-ish? Okay, around 29.3 for our arc length. Now, for the area of a sector, it's pretty much the same thing. The only difference is, instead of being a fraction of the circumference, it's going to be a fraction of the total area. So let's plug in over here. So my area of a sector is going to be 112 over 360. Same thing so far, but this time it's going to be times pi r squared. So pi times 15 squared. Okay? So with that being said, let's do some math. 112 divided by 360 equals, then times pi equals, all right, then times 15 again, and I get around, well, this is actually pretty nice. Area of a sector would be, was my calculator working correctly here? Where's my decimal? 200, let's see, 219.9. Is that what you guys got? 290.9? And so that would be what I enter as my answer for the area of a sector. Once again, I know your classwork packet only says you need to find arc length, but for a couple problems on your homework, I may actually ask you guys to find two things. I may ask you to find arc length and the area of a sector. Okay? Now, the next thing we're going to take a look at is on page 8. Can everybody please take a look at page 8? Once again, that would be page 8 of the classwork packet. And now we're going to take a look at example number 12. All right? Page 8, number 12. So I'll write that up here. Page 8, number 12. All right, so once again, they give us a circle, right? And I've got a diameter right here. This is a radius, that's 90 degrees. Then I've got another radius drawn there, and they tell me that there's a Another one right there. 127. VUT. VUT. Then I've got SR. And what's at the center there? W. All right. So, first things first. They tell us that the diameter here, okay, the diameter is 12. So what I could do if you want is you could say that the radius then is 6. It doesn't matter to me necessarily, all right, but just keeping in mind that I like to do everything in terms of the radius because those are the formulas that I prefer, all right? Now they're asking us here to find the length of UT. Now we got to be a little bit careful here, right? In order to find arc length, take a look at the formula. Theta over 360 times 2 pi r. I know the radius, which is 6. But I need to know this angle right here, which I don't yet have. So we're going to have to do a bit of back solving, okay? Notice this is a diameter, okay? A diameter means that I have a semicircle on either side. So if this is 127, this is going to add up with 127 to give me 180. So that's going to be 53 right here. Once again, where did I get 53 from? I subtracted 127 from 180. Then notice something, all right? Over here, okay, I have another semicircle, okay? I have this diameter right here, so this 90, this 53, and this angle have to add up to give me 180. How many degrees are left right here? Well, 90 and 53, let's add those together, and I get 143. Then, subtracting from 180, I believe I'm going to get 37 degrees. Once again, how did I get this? I took 53 and 90, added them together, and subtracted from 180. So this is 37. So guess what? Now I have my radius, which they gave me at the beginning, that's 6, and I also happen to know my angle. So let's plug in. So I'm just going to do 37 over 360 times 2 pi times 6. And look how awesome this is, because finally, at long last, you get to use a calculator. Your lives are so much easier. That's pi times 6. And I get, what do you guys say, around 3.9 or so. All right, that's my arc length. And then, if I do the same thing to find the area of a sector, all I got to do is write the formula. So theta over 360 times pi r squared. Same thing here, 37 over 360 times pi times the radius, which is 6 squared. And I just do the math using the calculator. So 37 divided by 360 equals times pi, using the pi key, times 6, and I get 11.6 for my area of that sector, okay? So again, bear in mind, as long as you can do what we did with the previous video, all right, with the two formulas for area of a sector and for arc length, and as long as you guys remember linear pairs and vertical angles, you should be able to attack most of these problems pretty easily. Me personally, I don't even bother to memorize the formulas because I remember it as fractions. If you can memorize pi r squared for area and 2 pi r for circumference, all you have to do is remember that area of a sector is a fraction of the area of a circle, and the arc length is a fraction of the circumference.